This is HRW913P093, planet Roton with a mass of, and then they give you the mass, and a radius of blah blah blah, gravitationally attracts a meteorite that is initially at rest relative to the planet at a distance great enough to take as infinite. The meteorite falls toward the planet. Assuming the planet is airless, find the speed of the meteorite when it reaches the planet's surface. Okay, this is a conservation of energy problem. So, I've set it up. Here's the before. You got your Roton of mass large m and a meteorite of mass small m, and it's very, very far away. So the radius is infinity. The energy that we have here has to equal the energy after. Afterwards, we've got the meteorite right on the surface, so that basically the meteorite is at a radius of 1600 kilometers. Okay, so the energy it has before is its potential plus its kinetic, which in this case, remember that potential energy is defined to be 0 at infinity, and the thing is at rest. So basically our total energy has to be 0. That is what it has to be. So when we're done, the total energy also has to be 0. But this time the energy is not 0 plus 0. This time the potential energy is, hang on, there we go, negative g m big M over r plus kinetic energy is 1/2 mv squared. Okay, and we want find the speed of the meteorite. So we want v. Okay. Oops. Beep beep beep. Too far. Okay, I'm gonna go full screen in a sec, but first I want to write down a couple of things, such as the radius of the planet is 16. Oh wait, no, I already did that one. The mass of the planet. I need to write down. The mass of the planet is, for me, 3.75 times 10 to the 24th kilograms. That's 4. Okay, now we can go full screen. Okay, so solving for v here. Well, if this all equals 0, I can move this to the other side. So basically, this is what I have. Alrighty. I've got little m's on both sides, so those go away. Goodbye. Alrighty. I'm going to multiply both sides by 2. Alright, so v is going to be the square root of 2gm over r. Basically, we've just done escape velocity in reverse. Okay. Okay, so put all the numbers in. Big M is 3.75 times 10 to the 24th. R is, now remember, you got to turn your R into meters. That's important. Everything has to be in standard units. Okay, and I end up with, let's see, I get 1.77 times 10 to the 4th. Oops. Whoa, what did I do that for? Weird. And since I put everything in standard units, that should be standard units as well. Let's go check that. Yeah, exactly. They just didn't put it in as scientific notation. So just to check that, remember with scientific notation, you move the decimal that many places. So I'm looking at 1, 2, 3, 4. I'm going to have this with 2 zeros on the end. So 2 zeros on the end. And yes, that's exactly what they have. So that's it.